Describing pairs of angles. So on this, in this unit, we're going to start talking a little bit more about geometry and shapes. So on our first example here, we're looking at a star, and it has a regular pentagon at its center. When you see the word regular, what that means is that all of the angles are going to be the same. So all of your interior angles, if you notice here, this angle is 108. So all of your angles are going to be 108 degrees. And it wants to know, the question is, what do you notice about the following pairs? So you've got X and Y. So if you look, X and Y are here. Y and Z are here. And X and Z. So X and Z. So X and Z are here. So X and Y, you notice, were on a line. Y and Z were on a line. X and Z are across from each other like this. Okay? So X and Y and Z were on a line, and X and Z were across from each other. Okay? And if we find the values of each variable, so what we know here is that if all of the interior angles are 108, because if that was regular, here's some things that we know, and I'm getting a little bit ahead here, but if this angle here is 108, the angle across from it is going to be 108, okay? So we know angle Y is going to be 108. This is going to be something that we're going to learn here. We know that angle X, if they're on a straight line, this is something that you might have learned in middle school if you remember. Those, if they're on a straight line, they add up to be 180. So if we do 180 minus 108, that's going to be 72. So X is going to be 72 degrees. Okay? So Z is going to be 72 degrees. And you can look at it two ways. It's on the straight line with Y, so 108 plus 72 has to be 180. Also, 72 is across from X, okay? So we know X is 72 degrees. Y is 108 degrees. Z is 72 degrees. And we also have V and W, okay? So let's try to figure out how we know those. Well, if we know that all of the angles inside the pentagon, all of these are 108, okay? And this little symbol here means that we have congruent angles, okay? So if we know that this was 108, we know this angle is 108 because those are across from each other. Then that angle has to be 72 right there. So W has to be 72. Now we have a triangle. Here's our triangle. I'm just going to highlight our triangle. We know that we have 180 degrees in a triangle. So if I do 180 minus 72, because I know that my two bottom corners, I'm getting full up there, my two bottom angles are both 72 degrees. I know that V is going to be 36 degrees. Okay, so let's talk about two vocabulary words that you really need to know, because when directions give you this, that's going to tell you how to find angles. So, complementary. Complementary, if you are told that they're complementary angles, it means they add up to be 90 degrees. So in this one, it means it's a right angle. Angles 1 and 2 would add up to be 90 degrees, or they don't have to be together. They can be like this picture right here, 20 plus 70 equals 90 degrees. So as long as the two angles add up to be 90 degrees, that means that they are complementary. So whenever you see that word complementary, it means the two angles add up to be 90 degrees. Supplementary means that they have a sum of 180 degrees. So if they're on a straight line, that's obviously supplementary, or they can be separate. So 115 plus 65, even though these two angles are not connected, they're still supplementary angles because 115 plus 65 equals 180 degrees. So know that complementary means they add up to be 90. Supplementary means they add up to be 180, whether or not they're touching. Now, adjacent means that they are touching. So adjacent means that they're together, they have a common side. So common side, here's the common side. That means adjacent, okay? Over here in this picture, these are non-adjacent, okay? So adjacent just means that they're touching, and then in the second picture over here, they're non-adjacent. So example 2, name a pair of complementary angles. So we have to find a pair of angles that are complementary. So we have to find a pair that add up to, they have to equal 90 degrees, okay? So if we add up here 37 and 53, 37 plus 53 equals 90. Now, I'm not just going to put 37 plus 53. I have to name those angles. Now, let's talk about naming angles. I can't just simply say angle A and angle S. I can't just simply say that because angle A, I don't know if I'm talking about at angle A. I technically have 3 angles at angle A. I have this angle at angle A. I have this angle at angle A. I also have this angle. So see, there's 3 different angles happening at angle A. So we have to be very specific. And you go in order, like the way that you would draw it. Like you wouldn't just say like A, B, C, because you don't draw it A, B, C. That doesn't make any sense right there, okay? So let me erase what I've marked here to get rid of all that, okay? So you name it the way that you would draw it, like without lifting up your pencil. So you could name it B, A, C, because that's the way that I drew it without lifting up my pencil. You could also do it, so if I get rid of my markings here, you could also do it C, A, B. So either way is appropriate. So angle B, A, C. And now on the other angle, there's only one angle over there. So you could call it angle S and that would be okay. But let's follow suit and we'll do it using 3 letters. So we would say angle R, S, T. And once again, that one could be, we could say angle, so R, S, T, or I could say angle T, S, R. So angle T, S, R would be okay. All right, supplementary angles have to be 2 angles that add up. They have to equal 180 degrees. So I have to find 2 numbers that equal 180, okay? So that would be 127 and 53. That would add up to be 180. So once again, we have to say it, we have to call it DAC or CAD. You can't just call it angle A. So let's say CAD and angle RST, okay? And adjacent angles, so those are angles that are touching. So let's say angle DAC and angle CAB, okay? We're not going to involve angle RST at all because that's an angle off by itself. Okay, example 3, find an angle measures. Angle 1 is a complement of angle 2. And the measure of angle 1 is 62 degrees. Find the measure of angle 2. So remember, if it's a complement, that means it has to add up to be 90 degrees, okay? So the way that we would do that is we would do 90 minus 62. Okay, so 90 minus 62 So that means that it would be, 28 degrees. That would be the measure of angle 2. All right, on 3, it's a supplement. Supplement means it has to be 180. So we would do 180 minus 47, and that would give us 133 degrees. And so that would be the measure of angle 3. Okay. On part C, so it says, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles from the ground. So here's our straight line. There's our angle right there. Find each angle. So what we know is that these two angles added up are supplementary, meaning that they add up to be 180. So that's why it's important to know what word, when supplementary, it means it's going to be 180. Complementary is 90. So make sure you memorize which word is which number. So these two things are going to be 180. So all we would do is add these up. So 4x plus 8 plus x plus 2, and it's going to be set equal to 180. Okay? Now, we got to figure out x first so that we can find each angle. So the first thing I'm going to do is combine like terms. 4x plus x is 5x. 8 plus 2 is 10. And that's going to equal 180. So the first thing I'll do is subtract 10. And that's going to give me, let's go over here where I have more room. So I have 5x equals 170. 170 divided by 5 is going to be 34. Okay. All right. All right, so x is 34. And so now if I want to find what each angle is, I would plug in. So here I would do 4 times 34 plus 8. And over here I would do 34 plus 2 to get each angle. So this angle is going to be 36 degrees. And this angle, let's see, 4 times 34 plus 8. This angle is going to be 144 degrees. Okay? Okay, so now let's talk about linear pairs. A linear pair means that angle 1 and angle 2, they share a common side. So angle 1, so it's very similar to being an adjacent pair. So angle 1 and angle 2 are a linear pair. Vertical angles are going to be angles that like form an X, okay? So angles 3 and 6, so like they're opposite from each other. And then angles 4 and 5 are vertical pairs. And vertical are vertical angles. And vertical angles, this is super important because this helps you solve a lot of problems. Vertical angles are congruent. Okay, that's your symbol for congruent. Okay, vertical angles are congruent. And that's kind of like a fancy word for equals. It's very similar to being equals. But we use congruent when we're dealing with shapes. We use the word congruent for shapes. Okay? So for example, identify all linear pairs and all vertical angles in the figure. So linear pair, so if we kind of make a list here. So linear pairs would be like angles 1 and 2, angles 2 and 3, angles 3 and 5, angles 5 and 4, and angles 4 and 1. So those would be linear pairs because they're sharing that side. Okay? Now, vertical angles are forming an X because, and now notice they have that straight side. So you got to be super careful with the angles here. Okay, so we have to be careful here not to use this side right here. Okay, so it's like we're taking that side out. It's like kind of take out the red. We want to use the angles formed by the blue lines. Okay, we want to use the angles formed by the blue lines. So angles 1 and 5 would be vertical angles. Angles 1 and angle 5 would be vertical angles. And then angles 4, okay, paired up with angles 2 and 3 would be vertical angles. So like this entire angle here with this angle here would be a set of vertical angles. Okay, so that would be our vertical angles because it's got to be formed by an X. Okay, two angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. Find the measure of the other angle. Okay, so if they're a linear pair, we know that they're going to add up to be 180. Okay, so they're on a straight line. And we don't know what 1 is, so we're going to call 1x. The measure of one angle is 5 times the measure of the other angle. Okay? So, we know that we have 5x plus x is going to be 180 degrees. Okay? So, now we have 6x equals 180. And then we do 180 divided by 6. And so x is going to be 30. And if we want to find the measure of each angle, we know that one angle is going to be 30. And if we do 5 times 30, we get 150 degrees for our other angle. Okay. All right, so for B, the measure of an angle is twice the measure of its complement. Okay, so we know we've got a 90-degree angle. Okay, and it's split here. The measure of an angle is twice the measure of its complement. So we don't know 1, and the measure of angle is twice the measure of its complement. Find the measure of an angle. So we know these two added up. So 2x plus x is going to be 90. So we have 3x equals 90. If we divide 90 by 3, we'll get 30. So x is 30. So we know one angle is 30 degrees. And 2 times 30 is 60. All right. So for the next one, two angles form a linear pair. The measure of one angle is 1.5 times the measure of another angle. Find the measure of each angle. So we know 1.5 x plus x equals 180. So we get, if we add those, we get 2.5x equals 180. So 180 divided by 2.5. So x is 72. So one angle is 72 degrees. And if we do 1.5 times 72, we get 108 degrees. Okay. All right. For example 6, which form a linear pair. So if we look and see which ones would form the straight line, okay. So it would be, if we kind of look in here, our which ones are on a straight line. So none of them are really, like, if it's asking like which ones are on a pair, it's kind of a trick question. So none of them really form a pair, because a pair would be 2. But it would be, you could see like angles 1 and 2 and then angle 3. So none of them really form a pair, because 2 would have to form a pair. But it would be like angles 1 and 2 with angle 3. Or you could say angle 1 with angles 2 and 3 would form those, okay? Or you could say like angle 6 with angles 5 and 4, okay? So none of them really form a pair. So on this one, it's kind of a trick question. So you would say none, because there's no 2 angles that form a linear pair, because none of them, no 2 angles are on a straight line. Now, which ones are vertical angles? Okay, so if we're looking for an X, so what I'm going to do is I'm going to highlight. If we highlight our X here, we could say angles 2 and 5. Okay, angles 2 and 5 form an X. Angles 3. Oh, let me highlight to make it so we can see it a little bit better. All right, if we do then we've got angles 3 and angle 6. Okay, angles 3 and 6, because you've got the X right there. All right, and then you've got angles, right here you've got angles 1 and angle 4. Okay. Okay, last set, very similar to like the goal problem that we did earlier, solving for variables. So we know that vertical angles are congruent. So we know like these 2 angles are congruent. So we can set 8x plus 7 equal to 9x minus 4. And now I can solve for x. So if I subtract 8x, that's going to give me x. And if I add 4, that gives me 11. So x is 11. Same thing for my y's. So I know that these are equal here. So if I do 5y equals 7y minus 34, if I subtract 7y, I get negative 2y equals negative 34. Divide by negative 2. And y equals positive, whoops, almost messed up there, positive 17. Okay. Same thing over here. If I solve for my y's over here first, I know that these angles here are congruent. 6y plus 8 equals 7y minus 12. If I subtract 6y, I will get a positive y. And if I add 12, I will get 20. And then if I solve for x, because I know these angles are equal, 4x equals 6x minus 26. Subtract 6x, and I'll get negative 2x equals negative 26. Divide by negative 2, and x equals positive 13. Okay, so you just set your parts equal that you know and solve. Okay, whereas in the other one, we added them. Okay, so if we go back up real quick, where was it? Okay, so here we added our parts and set equal to 180. So that was the difference. And then these, we set them equal to each other and we solve for x.